Hi, and welcome to Allen High School's discussion of chemistry at the 10th grade pre-AP level. Welcome back. Guess what, folks? This is our last unit, so let's jump right in. We're going to look at whether a reaction will take place and what determines the rate at which a reaction, not whether or not it will take place as much as how fast it will take place. And how far it will go. So this unit's going to talk about how fast it is and how far the reaction proceeds towards products. So the first part we want to talk about is collision theory. In collision theory, it's a theory, right? A theory is an explanation that tries to explain why certain experimental factors, such as temperature, increase the rate of a reaction. And the first premise, the theory has three premises or assumptions or claims, would be a good word, that molecules must collide in order for a reaction to occur. Hopefully that's pretty evident. If you're going to marry somebody, hopefully you're going to meet that person at some point, at least at the wedding, in order to get married. You certainly have to collide in order to fall in love. And that's true of molecules. There must be some sort of collision because we need some sort of energy to start breaking bonds. And then hopefully energy could be released in forming them. Now, the next one is that they must collide with sufficient energy. You know, you've probably met a lot of people out there and you're not really attracted to them. They're great friends. They might be nice people, good to work with in the classroom, but there's no spark. There's no energy there. And that's what we have with molecules. They need to collide, but they need to collide with sufficient energy in order for the reaction to occur. Now, that's critical because what that means is that not all collisions will lead to a reaction. There's a minimum threshold amount of energy that has to be met. This minimum energy is called the activation energy. It's like an energy barrier or an energy hill that reactants must collide with enough energy to get up and over the hill. Now, we're going to see a picture of this in just a minute, so I won't draw one right now, but we'll see that at the peak of that hill, we have what's called a transition state or an activated complex. It's a transition because it's a temporary state. Sort of like being engaged is a transition state to marriage. So it's called the activation complex or activated complex. So I was talking and writing at the same time. So really the activated complex or activation complex, both would work. Okay? Now, this is one of the key ones. This barrier or the existence of the barrier is one of the key premises that helps explain why temperature increases the rate of a reaction. Because if temperature is increased, molecules have increased kinetic energy. Remember, that's what temperature is. And really, if the temperature is measured as higher, the higher temperature measured is really a result of there being a higher kinetic energy. So if molecules collide with a higher kinetic energy, aka there's a higher temperature, then that in turn means more of them will overcome that difference. Okay? Now, the difference in energy between the activated complex and the reactants is called the activation energy. So there's two key differences that we have. The difference between the activated complex at the peak of the hill and reactants, that's our activation energy. If it's the reverse, so let me write it this way. Our activation energy, and this would be for the forward reaction, is equal to our energy of our activated complex minus the energy of our reactants. Now, so the activation energy is really a delta. You can think of it as that. You can think of it as a difference, as a delta. But we don't write that. It's simply a convention that never caught on. Now, the activation energy for the reverse direction would be the energy of the activated complex minus the energy of the products. So we can talk about that in the reverse as well. And then finally, there's one more that we want to talk about, and that's one we've seen before, and that's the enthalpy. And the enthalpy, remember, we use the symbol delta H, and that's our energy of our products minus our energy of our reactants. All right? Now, in the spirit of making these a little shorter, because you said you liked them that way, I'm going to stop here with the definitions, and then I'm going to move into a discussion of these activation energy profiles in our next video. So until then, this is signing off.